Hi friends, welcome to our channel. Let's have a look at problem 120, triangle. In this video, we are going to practice dynamic programming. So let me first give you the overall idea. So here we are going to use tabulation, right? So two important things are first, the interpretation of the table element. The second one is the DP update rule. So we are going to demonstrate this through this problem. So here we are given a triangle array. So we want to return the minimal path from top to bottom, right? So for each step, you may move to an adjacent number of row below. More formally, so if you are on index I in the current row, then you may move to either index I or index I plus 1 on the next row, right? So here we have two examples. Example 2 is a special case because it's just one number, right? So it's going to give -10. And the first one, actually it picks a minimal path which has sum 11. So here is the constraints of the following. First, the length of the triangle. This is the two-dimensional array, right? The outer array length is bounded above by 200. So originally it begins with length 1, the first row, and then each row becomes larger than the previous row in length. This is the third item, right? So the numbers can be negative, can be 0, and can be positive. So here is a question. Could you do this using only on extra space, where n is the total number of rows in triangle? Actually, we can do this. And also we can do this problem in place by modifying t, right? In that sense, that's O1, but also we can do an On, right? So first, I'm going to go from up to bottom. So I'm going to use this interpretation. So here I change this triangle to be t, just for convenience of writing here, also for convenience of explaining. So I'm going to interpret like this: Tij, the ith row, jth column, the ij cell, is the minimal path ending at this cell, right? So how do we get this ij cell from the upper rows? So either from the j-1, right, or from j, right? Because j-1 plus 1, you're going to get j, right? So then the update rule will be the following. So roughly, so means that I want to this element at the ij cell, the original triangle element, plus the previous cumulative sum ending at I-1 j, and the cumulative sum ending at I-1 j-1, right? We pick the minimal of these two. So by roughly, we mean that we use inbound the second index, let's see, j and j-1. We need these two indices, or we need to pick those that are inbound for the R-1 row, because its length is 1 less than the current row. So once you realize this 2-point interpretation and the DP update rule, especially the index inbound condition, so writing the code should be rather straightforward. So first, I'm going to get a length of this list, and then I'm going to do the update. So for I in range, so I'm going to start from the second row. So here we write 1 and then n-1. So the current length, just let's write with some redundancy so that you can make a correspondence with the explanation above. So this tells us the previous row has length, current length -1, right? So now for j in range, current length, so we want to set Tij, right? So first, let's get the current value at Tij. Also, we want to have the previous indices, which is either j or j-1. So let's also use a temp to get first pick out this one, ij. Then the value I want to set is to be used to update the value at the cell ij. So I'm going to use it as none, right? Then I'm going to check these two indices inside this pre. So though I use a for loop, actually it's just 2 elements at most. So for IDX in the previous, right? So if the index is inbound, it's less than the current length minus 1, right? And then if value is none, so we just need to set the value to be temp plus ti minus 1 idx. Otherwise, so the value will be the minimum of the pre-state, because it's not a none, so we can make the call minimum, right? So then temp plus ti minus 1 idx, right? So afterwards, so after this check, so we can set tig to be the value, right? So now we can return the minimum of ti minus 1, right? The last row, not I minus 1, negative 1. So now let's first run to check the result. Yeah, it passes the 2 test cases, right? So now let's look at the generic case. It passes all the generic cases. So in order to get more information, so you can actually print out this t, right? So for the first example, you can see the minimum number here is 11. So this is what we want to return. So this is the one way to write the solution, so which is actually in place, right? So in the follow-up, so the problem asks, could you solve this using OM? Yeah, actually we can do that. So let me copy this here. I'm going to change this method to be version v1 now right here. So what I want to do is I want to write a dp. So I'm going to set also the length of t, right? So here I'm going to write m plus 1. So here in this version, I'm not going to specify the interpretation. And then I want to finish it and then run it. I'll leave you to check if you can understand or digest the interpretation. So actually, if we print out something, which should be rather straightforward. So basically what I want to do is for row in t, so I'm going to reverse this. Then basically, then for in this is the n is not, let's see, iy in enumerate row. So we are going to update the dp like this. So dpi is updated through this. The min of dpi and dpi plus 1. So because the way we initialize this, because this is n plus 1, so this always valid. So plus the current value. Then finally, we just need to return dp0. So let me first run it. Let's see, what's the problem? So length plus 1, so reverse. And then for this, so dp will be min, not plus n, plus y. So let's run it. Yeah, it passes the 2 test cases. So you can also check for the generic case, which is very fast. So now what I want to do is to print out. So for after each row, maybe we can just print. So say print the dp status. So what you get actually this. So here in this dp, so we are actually from the bottom to the top. So basically, you see from this one, so you can get so we are actually using reverse. So basically, each position from smaller one, we this one, so we choose 1, right? So from this 2, we choose 1, we get 1.5, right? From this one, we get here. So then the last one is the one we are going to return. So now I want to ask two questions. So what's the interpretation of DPI? So that's the first question. The second question is, what's the DP update rule, right? So if you do the first, if you use this one as a walkthrough, so actually it will be rather straightforward. Let me do that for you. So DP, so the length is 4, so we can write 5 zeros first, right? Then we look at this element. So for 1, choose the minimal DP0, DP1, and then plus the 4, right? So this is the, say DP0 is the mean of DP0, DP1 plus the 4, right? So you get 4. So then you get DP equals 4, 0, 0, 0, 0. Then DP1 is going to be mean DP1, DP2 plus the number at 1. So as DP1, DP2 is 0, so 1, you get 1. So now DP would be like this. Right. So now let's look at DP2. So it's going to be mean DP2, DP3, then plus index at 2, so 8. So you are going to get 8, right? So now the DP will be something like this. So now you can see why we initialize it using n+1. So you will see DP3 is going to be DP3, DP4, right? Outer bound if you just use n. So the mean of this one plus the current number, so 3. So you get 3. So you're going to get this one. So this is the current DP state, right? So this from this 4 indices. So then if we look at the next row, so let's look at this row, that is 6, 5, 7, right? So then actually we are checking this 2, this 2, and this 2, right? So basically let's update DP again. DP0 is mean, DP0, DP1, and plus the current number, that is 6. So DP0 and DP1, the smaller one is 1. So 1 plus 6 is 7. So you get DP0 to be 7. And then we are going to look at DP1. It's going to be mean and DP1, DP2, plus the current row at index 1, that is 5. So DP1, DP2, smaller one is 1. So you get 6. So then the DP will be 7, 6, right? So now let's look at DP2. That's going to be DP2, DP3, plus the value at 2, that is 7. So 2 and 3, so gives you 8 and 3, plus 7, that is 10. So you are going to have this is 7, 2 and 3, 3, this 10. So now let's look at this row, the row that is 3, 4. So now let's look at DP0. It's going to be mean DP0, DP1, plus the value at the index 0. So the smaller of this one is 6, so we get none. So then let's update this DP. So you get 9. And then let's look at dp1. It's going to be min dp1 dp2 plus 4. The smaller of dp1 and dp2 is 6. 6 plus 4 is 10. So you're going to have dp equals this 10. So now let's look at this row. It's just a 2, right? So then dp0 is going to be min dp0 dp1 plus 2, that is 11. So then the dp will be 11. So let me check if this is the stem. Yeah, 11, 10, 10, 3, 0. 11, 10, 10, 3, 0, right? So in other words, for the index upper, so it means as you each round you are going to check a position. It means from the bottom up to this position, the minimal cumulative path sum, right? But in a reverse direction. So I guess we spent too much time on the details, but this is for this follow-up questions. Hopefully this very detailed walkthrough help you understand the second way. To me, actually, if I want to write, maybe this is the first way I want to write, and then we'll think slightly deeper to write the second way. With that said, thank you for